a distinction between a right triangle and a special right triangle?
Special right triangles have
the other angles.
Yeah, so like, and that is, special right triangles are driven by very, very specific angles. They only work with very, very specific right triangles. So let's do a little exploration. Look, today's one of those days where there is only one mathematical process. That's it. It's one thing. And either you get it or you don't. I don't know how else to teach this. It's a very simple process. So I am drawing squares. Cool? Can y'all like give me the artistic ability to draw some squares? So I'm going to draw this square right here. And on your homework or other assignments, it says this side is 1. So because it's a square, how long is this side? 1. And this side? 1. And this side. And then it might have asked you how long is the diagonal. So if you don't know anything about special right triangles, you would default to a squared plus b squared equals c squared, right? So let's do that. A squared plus b squared equals c squared. 1 times 1. Plus 1. 2 equals x squared. Square root of both sides. So x equals the square root of 2. Cool, right? Let me draw you another square. Cool? Light bulb goes off. There's 2 different ways to solve this problem. You would probably jump to doing what first for solving for the length of the diagonal?
A squared plus c squared.
Yeah, but aren't those similar polygons? So their side lengths should be proportional. So you could set up a proportion if you wanted to. Is anybody going to do that?
no.
No, you hate proportions, don't you?
Yeah.
I get it. So we go back to a squared plus b squared equals c squared. 4 plus 4 equals x squared. 8 equals x squared. And then what is the simplified radical? 2 square roots of 2 equals x. Whoa. Light bulb, anybody?
Yes.
Not right. Yeah? So you should be able, Bet, to
Three square roots of 2.
So is that the light bulb that you had?
Yeah.
Yeah, so
It's just like wherever all 4 numbers of one.
so remember the topic today is special right triangles, not special squares.
That makes 2 triangles.
But what kind of 2 triangles are there? That's the whole point. What kind of right triangles?
Special right
Not special right triangles, because there's 2 different types of special right triangles.
The 45 degree.
Whoa, where'd you get that from?
That's crazy. So I actually saw it on the paper.
Perfect. That's called using contextual clues. When you draw a diagonal in a square, that diagonal bisects that angle. We talked about this during the quadrilateral unit. So we got a 45 degree angle here, a 45 degree angle here, 45 here, and 45 there. Thus unleashing the monster, the 45, 45, 90 right triangle. Yay, we're there. So 45, 45, 90 right triangle is one of the special right triangles. Alright? So in a 45, 45, 90 right triangle, you have to see 45, 45, 90. When you see a 45, 45, 90 right triangle, there shouldn't be any calculator skills available. You should be able to do all of this mentally. So let's try the hard one. 7. I want you to solve for x and y.
X is 7.
X is 7. Can you tell me how you know that?
Because the size of the equal.
It's an isosceles triangle. See that?
So then,
Or it's half of a square. So this is 7.
y is 7 square root of 2.
Y equals 7 square root of 2.
Okay, see.
Now, what's actually going on here, besides just recognizing patterns. Because if I gave you a triangle that looked like this, could you go backwards?
No.
No, right? Because you don't know what's actually going on. So in a 45, 45, 90 right triangle, to go from a leg to the hypotenuse, you multiply by the square root of 2. That's it. Multiply by the square root of 2. That's the only thing that we're doing. It will always work no matter what. Or, conversely, to go from a hypotenuse to a leg, you divide by the square root of 2. Those are the only two things that we're doing. You either multiply by the square root of 2 or divide by the square root of 2. That is half of the learning we're trying to accomplish today.
So
Yes, sir.
for that one, if you're trying to find x, would that be?
So that's what's printed on the formula chart. That's like the formula to find all that stuff. So whatever x is, like give x a number. 7. So if this was 7, this would be 7, and this would be 7 square roots of 2.
So what if you're
In these questions that you're about to ask, that's the kind of the purpose for today. Like, what if it's not just a 7 there?
okay?
Did I take it out of your head? Or
Kind of.
Go ahead, ask your
What
question.
if it's a whole number? Like what if it's
What if the
not-
hypotenuse is a whole number?
Yeah.
Then you just divide by the square root of 2.
How do you divide by the square root?
And that's the purpose of the class
Whole
today,
beans.
right? So there's only 4 different scenarios that will happen. I'm glad that you recognize that. 4 scenarios. This could be a whole number, or that could be a whole number. Those are 2 scenarios. The other 2 scenarios, this could be a radical, or this could be a radical. We'll tackle all 4 of those scenarios today. I'm always going to tell you guys, either multiply by the square root of 2 or divide by the square root of 2. However fast your brain processes that information is up to you. Okay, I can do all of this in my head. Most of you guys can't. So, first one. Feel free to write as much or as few of these as you choose. We have a 45, 45, 90 right triangle. I will always abbreviate these as SRT for special right triangles. Then I'll be, please don't dodge these problems. Okay, just me. Anybody catch that joke?
Can you say it again?
These are SRT triangles, special right triangles. Please don't dodge these triangles. Thank you. Right? Me and you. We're here because Dodge makes the SRT 10. The SRT 8. That's their like Saline Mustang, their Cobra Mustang. Dodge has the SRT version. Don't dodge these. Anyway, this is a 45, 45, 90 right triangle. If this side is 9, how big is this side?
9.
9, because it's an isosceles triangle. How do you get from a leg to a hypotenuse?
Multiply by the square root of 2.
Multiply by the square root of 2. So 9 times the square root of 2 is
9 square root of 2.
That's it, guys. Once you have 9, 9, you can Pythagorean theorem if you want to, but then you have to simplify radicals. Or you can just multiply by the square root of 2. The biggest difference between regular geometry and pre-AP geometry is you guys can do this in your head. Other kids have to see that written out. I get it, dude. Right? Does anybody kind of seeing a pattern here? Can you like tell me the pattern?
You just put the number in front of square root of 2.
Yeah, I'll take that.
The hypotenuse is always whatever the leg or sides are, and then square root.
So can you use the number, like the words whole number and radical in your like?
So the legs are always whole numbers, and the hypotenuse is always.
In a perfect world, you'd be right. Here's what I'm looking for. If the leg's a whole number, then the hypotenuse should have a radical. So would it work the other way? If the hypotenuse has a radical, the leg should have a whole number. Now what if, this is what Claire asked, what if the hypotenuse is a whole number? So that you go back to the process. How do you get from a hypotenuse to a leg? You divide by the square root of 2.
Isn't it already just 5?
10 divided by the square root of 2. So you think the answer is 5.
Well, because the other one is
No, that's
Oh,
an
wait,
S.
never mind.
That's an S.
Oh.
Well, can I just make it an X so everyone's clear on it?
You
So we're-
can divide it.
That's a great question. I'm glad that you asked. So is this an appropriate answer?
Yes.
Shame, shame, shame. No, sir. You are never, ever, ever allowed to have a radical as a denominator. Doesn't work. You have to get rid of that.
So times squared, or squared, both sides.
Take the square root
Oh,
of the
you
numerator.
you square both sides.
No, you multiply by the number 1.
With the
What?
No, because you're not thinking inside the box. Times 1. The most disgusting form of the number 1 you could ever think of. But what that does is it rationalizes the denominator. And watch what happens. 10 times the square root of 2. 10 square roots of 2. And please, the square root of 2 times the square root of 2.
Square root of 2.
No.
2.
Wait,
And it is the square root of 4. But what is the square root of 4?
2.
2. So skip a step, right? Skip a mental step there. Now, are we done?
no.
10 divided by 2
That's 5.
is 5
5
square roots of 2. So this 10 and 2 will kind of cancel each other, will simplify to that. So if y is 5 square roots of 2, then
That's 5 squared.
x is 5 square roots of 2. Now, does the pattern hold true? The hypotenuse was a whole number, so the leg has a radical. What is the only radical that we're dealing with right now? The square root of 2. So what you're saying is, I thought you guys were messing with my class. You guys should ask Ryan. Ready?
Right, know this?
I don't think so.
6, right? Oh, 3 square roots of 2. 3 square roots of 2.
How did you do that?
Because it's 6 divided by 2.
Oh, okay. So, are you trying to show us something?
I'm trying to show you a mental trick here.
I see it.
What is it?
Tell me.
3 square
Five
roots
by
Do you want me to
square
tell you?
That's
It's
crazy.
half the
That's absolutely insane.
Because 3 times 2 is 6, 5 times 2 is 10.
Perfect.
So for 18, would it be 9?
And
So
2
if-
is 9 squared.
If you have a special right triangle, and I know I'm breaking a lot of rules here, is that a 45, 45, 90 right triangle?
You don't
No,
know.
I didn't. My bad. But let's just, for speed's sake. Jacob asked, if that's 18, then what should the legs be? Because this is the only radical we're dealing with. And what's 9 times 2? 18. It always works that way. Always, when they're like that. You guys are making some big leaps right now. Now do mental, yes ma'am.
What if it's a prime number?
What if it's a prime number? So it's not necessarily the fact that it's prime, because 4 is not a prime number. 5 is, 7 is, 9 is not.
11 is.
But it's what if it's an odd number? Okay, so we'll get there. Trust me, I know where that's going.
But what if the hypotenuse is like
Let's just celebrate. Let's practice this. This is the hypotenuse is 24.
12 square root.
Cool.
Yeah.
And so you see how like 34 responses in 52 minutes that these questions should be quick. Right? And I'm giving you guys 2 different answers here for like double the fun. Or double the hate, because if you get one wrong, guess what? They're both wrong. Sucks to suck.
It's square root of 2.
8 square roots of 2.
Are we allowed to use decimals?
No, absolutely not. No decimals allowed. And just like giving away free information all day. No. If you put a decimal in your test, I can't just give you like partial credit. I have to count it wrong.
Why is that?
Because the whole test is dealing with radicals, right? Simplified radicals, all that stuff. So in the last one, when I was like, okay, either if you give me a decimal answer, I get it, you know what you're doing. But as we practice this, you're not really like simplifying a radical. You're just operating with radicals. Does that make sense?
Yes.
I'll get to that later. Hey, there's your prime number.
7 square roots of 2.
Did it matter though?
hypotenuse or something.
Yeah, what if it's 16?
But can we do this one?
Yes.
Okay.
With
And
the
then
leg.
here's where I get to nerd out. Okay? There's only 4 scenarios. Here's the easy scenarios, the ones that you guys should be able to do rapidly in your head. Easy scenario. 6, 6 on the bottom.
6 squared.
So that implies that there is a whole number here.
Yes.
Okay? The other easy scenario, which you have not been presented with yet, is if the hypotenuse has a radical.
So that's 7.
Oh, 14 and 14.
7 and 7.
What are you?
It'd be 3.5. No.
Oh, because you divided by.
Because look, if you forgot, you just take the hypotenuse and you divide it by the square root of 2. So sometimes mental tricks aren't the best if you don't remember what's going on. These are the easy scenarios. This generates a whole number on the leg. Okay? So if you have a radical on the hypotenuse, you can just drop it off. If you have a whole number on the leg, you can just tack it on. Okay? Now the other 2 hard scenarios would look like this.
So that's
5 squared.
Okay? And then conversely,
6. Just 6.
6. If you don't remember, 3 square root of 2 times the square root of 2, that makes 2. And 3 times 2 is 6. Now the one that I've been holding on to.
That's the
And we're
Would
not
it be
allowed to use.
4.5 squared to 2?
No.
4.5.
That's 9, never mind. It's
9
5.5
9
squared
halves.
to 2.
No decimals allowed, bro.
9 over 2
I know that.
square root.
11 over 1.
So when we did it like this, right? What's half of 10? Half of 10, right? But we were able to simplify that to what's half of 11?
5.5.
5.5.
And here's why that works. 11 divided by the square root of 2, multiply it by 1. 11 times the square root of 2 is 11 square root of 2. The square root of 2 times the square root of 2 is 2. I cannot simplify that, so that is my answer. That's the nastiest version I can think of. And that's your answer, 11 square root of 2. So 11 square root of 2 divided by 2. So if that's 11 square root of 2 divided by 2, then
That's 11 squared.
it's the same thing. You ever say something so many times it loses meaning? Right? That's the square root of 2 today for me. I've said it 1,000,000 times. So what I want to do in this next little process is the next 10 questions I gave to all the regular kids as homework. I think we can breeze through these in 2 or 3 minutes. Now look, here's what's happening. Like there's people that get this, right? They're like solid on it. And there's people that don't necessarily get it. So I'm going to show it to you. Give me a 1, 2, 3 break before you splurt something out. So it gives people time to process. Here we go. 1, 2, 3. Good? Is there anything else I can say to help with that? We're just to go from here to here, multiply by the square root of 2. Alright? 1, 2, 3.
7.
Okay, 1, 2, 3.
7 squared to 2.
Good. 1, 2, 3.
14.
14
squared to 2.
Perfect. Alright, it's gonna get a little hairy here.
8 square root of 2.
Is this 8 square root of 2?
16. Right? 36.
16.
8 times 2. 16. So that's 8 square root of 2 times the square root of 2. Remember, if you have a radical here, you should expect to see a whole number on the hypotenuse. And that whole number is generated by 8 times 2. 20.
12.
Yeah.
Right? So you see how the practice really helps. In this scenario, we're just taking the hypotenuse and we're dividing it by the square root of 2.
Yeah.
12.
13, 9.
Good. Oh.
Square
Square
root
root
of
of
2.
two.
The square root of
2, square root of 2 divided by 2.
Ooh, that's a weird one, isn't it?
What?
1 times 2.
Oh.
2. So again, 2 divided by the square root of 2. Don't be too proud to hand math. Square root of 2. Right? Or right here.
4.
8.
8. It's gotta get bigger. Okay, so there's the first huge chunk. I consider that the easy chunk. Now, I consider that the easy chunk. Everyone else today has loved the second chunk. I don't know why. They just love it. The second chunk is the other special right triangle. Are you guys cheating? The 30, 60, 90 right triangle. Here's how the 30, 60, 90 right triangle has been derived. That is an equilateral triangle. Cool? So if this side is 1, let's go with 2. That side's 2, 2, and 2. And then when we did our 9-point circles, I asked you guys to draw an altitude. Or an angle bisector. Or a median. Or a perpendicular bisector. It's all of those. So I want to know how big is this piece and how big is that piece. X is 1. How did you get that? It's a bisector. That altitude cuts that equilateral triangle in half and creates 2 isosceles triangles. Pretty sure that was part of our definition when we talked about equilateral triangles. So then, now you're stuck with solving for y. A squared plus b squared equals c squared. No, you're absolutely wrong. You're halfway, like almost 100% off. 1.7. You said 3.
Yes.
No. Okay, so we get 1, 2, and the square root of 3. Now let's try it again.
X is 2. That x is the square root of 6.
The square root of 4.
6.
If you don't know, math it. A squared plus b squared equals c squared. Plus 4 equals 16. Two square roots of 3.
Oh.
Wouldn't that be just 6?
That's weird. No.
So
2 square root of 3 is the same as the square root of 12. No, is it not hitting it?
Yeah, it's okay because you added up all the different lengths. Or it's half of each side length and then square root of 8.
How big is this one?
3.
3
square roots.
There we go.
Oh, I worked this out.
What?
This one's hard.
This one's tough, right? Because there's 2 different operators going on here. So here's what I need you guys to draw this in your notes. And I'm gonna go super elementary on this for you guys. This is a 30, 60, 90 right triangle. It's a 30, 60, 90 because when you drop an altitude in an equilateral triangle, it cuts that 60-degree angle in half and gives you a 30, 60, 90. So there are 3 numbers that drive this 30, 60, 90 right triangle. There's 3 numbers. 1, 2, and the square roots of 3. I have to put those numbers, I still to this day, 12 years later, label my special right triangles, my 30, 60, 90s. So I'm going to take these numbers and I'm going to label this triangle. I always start at the 30-degree angle. What do I do there? Start. I start there. So if you put a star there, it's going to help you further along in the process. So I always start here, and across from this 30-degree angle is the first side I'm going to label. First implying number 1. Then I go to the hypotenuse. The hypotenuse. Get it? And what's the only number I haven't used? Square root of 3. So the book says the short leg is 1, the long leg is the square root of 3, and the hypotenuse is 2. I like my method better. It's tried and true. It stays the same. So in this scenario, this is my roadmap to how I'm going to math. You get a number somewhere, 5. You use that roadmap to solve for every missing side that you have. So how do you get from 1 to 2?
Times 2.
I just made it up, right? So to get from here to here, times 2. So 5 times 2?
10.
Cool, right? If you have it labeled correctly, it's not that bad. Now the one that always gives people problems is operating from here to here, the short leg to long leg math. How do you get from 1 to the square root of 3? You have 2 options. Multiply by the square root of 3 or divide by the square root of 3.
Multiply.
Why would you say multiply?
Sounds easier.
No, because you're going.
Because it's getting bigger, right? To go from the short leg to the long leg, you must increase the number, so you have to multiply to make it bigger. And because 1 times the square root of 3 is the square root of 3. So I need to take 5 and multiply it by the square root of 3.
So is it just the bottom one?
Never the bottom one, never the left one, never the right one. It's always opposite of the 30-degree angle is your one side.
So
So,
the one side is always.
Because as soon as I change the question, does your bottom, left, right, top, middle help you?
no.
It doesn't. So you start where? Why does he keep saying it like that?
So we put a star.
It's a star.
So you always start opposite of the 30-degree angle. 1. Go to the hypotenuse. And then the x side is your square root of 3. So now we're starting in a completely different location. The star is there. A star is born because I can't do that. That is impossible to do. You can never math around the star. You can't do it. Impossible. So that's a huge roadblock. That should signify to you that you can only move this direction. How do you get from 2 to 1? Divide by 2, so 6 divided by 2 is
3.
3.
And then 3 is square root of 3.
And then multiply by the square root of 3, so you get 3 square roots of 3. The intricate part of this is you could be multiplying one direction, dividing in another, or you could be dividing, multiplying. All it depends on where you start your problem.
Star.
Yes, sir.
So is it always the one like side? The one side is just adding to the square root of 3.
Not always. So I see you're trying to make some connections. I can do that in my head, but can you? So again, going back to your labels really will help kind of like figure some stuff out. I start here, 1, hypotenuse, and square root of 3. So to go from here to here, multiply by 2. 5 times 2 is 10. Simple. You can't operate with this. Going this way, you multiply by the square root of 3, and 5 square roots of 3 times the square root of 3. The square root of 3 times the square root of 3 is 3, and 5 times 3 is 15. So sometimes they're pretty numbers, sometimes they're not so pretty numbers. Right? there is a bunch of icky situations that could happen here. Like a lot of icky situations that could happen here. For instance, said problem that's about to pop up. Is the labeling helping you guys? Okay, so somebody do it just like Victor would.
Star the third.
What you were?
Start the third.
No, you're not saying it right.
Bro, you gotta say what?
Start at the 30.
Okay.
And then you do times
Baker?
You divide 4 by 2.
No.
No, you label M as 1.
Opposite of the 30-degree angle, you always start opposite of the star, 1. Then you go to the hypotenuse.
Oh, that's
Yeah. Yeah.
Then it finally hit the hypotenuse,
Yeah.
right? It's just small things, guys. And now we have the ability to apply the mathematics. You only have one direction you can go. You cannot math around the star. Can't do it.
Kind of close.
So you have to go this way.
Not 2.
4
Oh,
divided by the square root.
So I have to do 4 divided by the square root of 3. Throw up noise.
And then you just times it by 1.
Multiply it by 1.
This is 45.
Equals square root of 3.
Oh,
Good.
no.
That doesn't help me at all.
Square root of
Square root of 3 over the square root of 3.
Thank you. I was really hoping someone didn't say multiply it by the square root of 2 over the square root of 2.
Oh yeah, that'd be terrible.
Why would you do that? So multiply it by 1. Another beautiful version of the number 1. So multiply across 4 times the square root of 3.
It's 4 square root of 3. There you go.
The square root of 3 times the square root of 3.
Oh, that's.
Yeah, that's gross, isn't it? That is now your effing answer. Or your F answer. It's okay to have fun while you math. So I see the icky sticky. I don't like that because what do you have to do with that number? You have to multiply that number by 2 to get to the hypotenuse.
So 4
8
divided by 1.
square root of 3 the opposite.
Ew, right? That's your answer. And you need to be comfortable with answers that look like that. Ugh. Now, it's not as bad when you have a multiple of 3 over there. So when you have a multiple of 3 opposite of the 60-degree angle, it's not as terrible. 1 hypotenuse in square root of 3. So now we're doing 9 divided by the square root of 3.
9 square roots of 3.
It's 3 square roots of 3. No, you're absolutely nowhere close. And it's funny now, but it's a slap in the face on your test. This is 3 square roots of 3. You don't get that 4 square roots of 3 divided by 3. And then multiply that by 2 and you get
6 square root of 2.
Wait, 6.
6 square roots of 3. So again, like there's 6 of these on your quiz, and there's 2 of them that you haven't seen yet. And you want to see those 2?
Yeah, that'd probably be a little bit.
Okay. Which one do you like better, the 45, 45, 90 or the 30, 60?
45, 45.
Y'all like those better?
Yeah.
Yes.
Okay.
Isn't this our homework?
Oh, it's
Yeah,
gonna
it's
be like
right
the
there.
bicycle.
Oh, yeah, you're right. My bad.
That's fine.
Okay, so look, this takes it from a basic read and recognize problem to a really an application problem. I'm looking for how big is y and how big is
It's
x.
because if the
You just
altitude, you do the altitude on that one, and then it makes 2 different triangles.
So, do you have the ability to drop that perpendicular line there? Absolutely, you do. So So you can, so this becomes 90 degrees,
And that becomes
and this
5.
becomes a 45, 45, 90 right triangle.
And then
Wow.
the altitude.
So how long is this dotted line?
5.
Ah, square root of 2.
Which means how long is this piece right here?
5 square root of 2.
So from here to here is 5 square root of 2.
And then you add that to 10 in order to get
Multiply that by the square root of 2.
So 5.
5.
Right?
Yeah.
You see it? You see how like you were on the right track, but you did the wrong kind of math?
Yeah.
To find x, when you do 5,
And that's the part that everyone loses points on. Here, this is the purpose of this problem. How long is x?
10 plus
10,
2.
Yeah, you're right. So x is the quantity 10 plus 5 square roots of 2. But like, how do you answer that on your quiz?
x,
Is it 15 square roots of 2?
No, definitely.
Absolutely not.
10 square roots.
And I'm glad you said that because everybody does that. And I don't understand why. That's like saying apples plus bananas. If you do apples plus bananas, you get grapes.
No.
No, so these are two separate food groups. Guys, that is the answer.
Wait, what?
Yeah, that is the simplest way to do it is saying 10 plus 8.66. Huh? Yeah, it's less math, but that's the way the answer really is supposed to look. I'm just trying to show you guys that because you will see it on your quiz.
How do you multiply a decimal by a square root
You don't.
or something? You don't?
So, like, literally, what I'm asking you guys to do is to not put decimal answers. Like, the square root of 2 is 1.441.
What I'm saying is, what if we're given a decimal? How do you multiply it?
So, like, on your homework, I hate
Yes.
that question because it's 3.2 is a leg. So, you just say that the hypotenuse is 3.2 square root of 2.
Okay.
That's
Well,
all.
yeah, I thought you said you didn't want
Yeah, I
this.
mean, I don't want that on your test. And then here's this question, too. Make sure I do this right. Oops. Like, all right, so you see where this problem is kind of going. That same process, how do you start it?
You do
Well,
that.
the
And
altitude.
then you.
Which makes
it's a 36.
No,
That's a 36. That's crazy.
That's 9.
start.
And then
1,
2, square root of 3.
So that's 9. And that other side is like
Oh.
9.
So your 1 is 3, your 2 is 6.
3 square roots of 3.
I know that.
3 square roots of 3.
Yeah, this makes sense.
And then-
3 times 2, so 6.
Now, here's the question. X equals what?
X.
35.
Oh, 35 minus
Minus
3
3.
square root of 3. Yeah.
Yeah. So this whole thing is 35. And then I have to come back 3 square roots of 3 to determine x. So it's that 35 length less that 3 square roots of 3 length, not drawn from scale. Crazy, right? So look, this is 6 questions on your quiz. It's a 15 question quiz. Nothing super terrible. There's a couple of straight up Pythagorean theorem questions. Is it acute, obtuse, or right? Those are 3 questions. You have to write acute, obtuse, or right. And then what is the third Pythagorean triple? Then the last 6 are those 45, 45, 90.
When is the quiz?
Friday. So we have an additional day of practice tomorrow. So do we need more help in Pythagorean theorem? Pretty good. Do we need more help on special right triangles?
Yeah.
Maybe. I have a whole day dedicated to that tomorrow. If you don't do your assignment tonight, and it's not graded, the one that you picked up, I'm not going to know how to help you tomorrow. The goal is cleanup crew, come in here and kind of just go over some specific questions you guys had on your assignment, and then give you the book work in class to work on. Guys, if you don't understand special right triangles, then you will never be able to do the unit circle. So I draw it like this because this is exactly how it looks like on your quiz. And on your quiz, this accounts for 15 responses. Watch, and here's what I expect you guys to do. There's going to be a blank here, a blank here, 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 and here. Then there's going to be coordinate locations for each of those. So look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 responses there. I can teach this to you in 30 seconds. So all of this is in radians. It's called the unit circle because this circle has a radius of 1. It has a radius of 1. So if I gave you guys a 45, 45, 90 right triangle with a 1 right here, you should be able to figure out how big this piece is.
But what about the curved side?
The square root of 2 over 2. So to get to this coordinate location, you would go over the square root of 2, up the square root of 2 over 2. And here's how I do it. I just want you to watch this even though you're not going to remember it. This circle has a radius of 1. So you go over 1 and up 0 to get to this location. You go over 0 and up 1 to get to this location. Who knows how to count?
Me.
Not me.
I do. Look, here's how you count. 1, 2, 3. Ready? 1, 2, 3.
Whoa.
Here's how you count. 0. 1, 2, 3.
What?
Oh,
But wait! Everything gets halved. And any number that's not a 1 gets a square root. There's 10 responses there. That's something you can probably memorize.
Yeah.
And then you have to figure out the radian equivalence. This is 0, pi over 6, pi over 4, pi over 3, and pi over 2. And that's something we're going to spend all day Monday, all day Thursday doing. Is generating this. But unfortunately, all we did was this quadrant, and guess how many more there are?
3 every other quadrant.
So there's 15 in the first one, there's 3 more. That means that there's
60
40.
responses.
60 of them.
Okay. I thought
It's
it
really
was
about
like-
56 different responses. On your quiz, it's just quadrant 1 question. And that's the exact same question as your test. Just memorize it. Rote memorization.